Okay, so our recording's good. Get your hair good. Get everything good. Get your angles. Yeah. So so everybody, this last name might sound familiar because today I have one of our own. This is Mr. C's son, the great Gregory.
What's
So
up?
I got Gregory here with us today because he works at Amazon now and has taken quite the academic trip to get there. But that's enough for me. I'll let Gregory introduce himself.
Hey guys, nice to meet you all. Even though it's remote, my name's Greg. Back in the day, they called me Mini Vinny, Little C, all that stuff. I got it. Basically, all my days off I spent at the gym and like just watch him shoot. You'll learn everything you need to know. But yeah, so I grew up in Queens, New York, in Jamaica, Queens. For those of you who know the area, went to school like nearby in Queens and like high school in Manhattan at Regis, and then I just finished my bachelor's in mechanical engineering back at MIT in 2018.
Wow. Okay. So what was your like college application process like?
Yeah, so that was a whole cycle. My high school had a really great setup. Basically, I applied to 7 schools. Like 3 of them were like reach schools, so schools like MIT or things that are a little beyond what you think you could do.
Hmm.
And then there were like kind of like safety schools at the bottom, like that are like schools that you're pretty confident you could get into, your credentials meet it, you would like the school if you got in. And then there's this like a middle set of 2 or 3 schools where it was like these schools I'd be very comfortable going to. There's a pretty good chance I get in, but it's not like a safety net. There's a chance I still don't get in.
Yeah.
So I went through that whole application process and I got really lucky. And I got into one of my reach schools, which is pretty fun.
That's awesome. What were
Yeah.
some of the other schools that you applied for?
Yeah. So reach schools, I applied to Princeton and John Hopkins. I didn't get into Princeton, did get into Hopkins. And then safety schools were SUNY Binghamton, Villanova. I think what was the other one? Cooper Union.
Nice.
We were looking at, and then some of the other ones I looked at. Looking about it now, I don't know why I did, but like Lehigh University and UCLA I also applied to because I was a big college basketball fan too.
Oh, nice. Yeah,
Yeah.
I went to Syracuse, so boo UCLA. Yeah, I actually I visited SUNY Binghamton during my own college process, and that was a fun campus. Um,
Yeah.
but yeah, it's cool. It's nice that you apply to like a little bit of West Coast, some East Coast, like kind of like give yourself options. So, but you ended up at MIT, and if you get into MIT, why would you not go, right?
Exactly. Yeah. And honestly, they had I was a little hesitant at first, but when I went over there, it was a really, really receptive community. And a
Mhm.
lot of people who have like this imposter syndrome feeling going into this like environment, like that kind of gets wiped away first thing because everyone has like a great humbleness to them. Even like the professors and PhD students really know that there's so much more to learn and they are not the experts in the field, even if they feel like they know a lot.
Yeah. Yeah, that's awesome. There's like imposter syndrome, like feeling like you don't belong. That's
Yeah.
something that a lot of times we never really leave, and like we don't leave
Yeah.
behind us. And every time we come to a new situation, but it's great. That's you found somewhere where just like a bunch of people that are like-minded. When you're in a comfortable place with a bunch of
Yeah.
people that like learning, it's easy to lose that and lose yourself in the situation.
Yeah. You summed it up pretty well there, actually.
Yeah. Um, so you studied mechanical engineering. So the
Yep.
last couple of people I've had on this podcast video interview series have been PhD students. So they're like 28, 29 years old, but they're
Yeah.
still in school, still doing research. But you just did your bachelor's and then moved on. So this is a different perspective on that. So why don't you tell me a little about that?
Yeah, so I considered doing a PhD and also considered doing a master's. I still think I plan on doing a master's in the future.
Mhm.
But for me, like after I graduated with my bachelor's, I didn't really know why I wanted grad school. Like some jobs, like some fields require for you to get in. So like for example, teaching. Eventually, you need to get your master's.
Yep. Been down
However,
that
a
road.
place like within engineering, mechanical, software, that field is really kind of just skill based. Some people don't even have to like most people have their bachelor's, but very few will like go like straight coding from high school
Mhm.
and will get hired at these companies because they have the skill set and they can prove so in an interview.
When you say
Um,
straight coding, what do you mean by straight coding?
Oh, by straight coding, sorry. I mean, like they took a pure software track. They went on their own, like like middle school, high school, learned how to code, like do iPhone applications or Android applications, or learned how to like use Python or like web design, kind of like using the internet because a lot of people do that these days.
Yeah.
And then if they show that they're really good at those skills, like you just get an interview, and then if you do well, they're going to accept you.
That's a good
Um,
that's a good field to go into because like I practiced civil engineering when I was in my undergrad and grad program,
yeah,
and when you're building bridges and roads and buildings, everything is highly standardized. Like you can't afford to mess up, so you
yeah,
have to have those degrees. But if you just get really good at coding, everybody needs somebody who's good at
yeah,
software. So if you can do that, you can bypass all those systems.
yeah. Oh yeah, but definitely for mechanical, 100% need the bachelor's. It's like
Yeah,
you need it. There's just so much you need to learn, and so many like standards you have to know, like you're saying. Um, but yeah, what was it? I kind of lost track of what I was saying here.
that's all good.
Um, but yeah, so I was trying to decide whether I should do grad school or not, and I didn't really know why I wanted to like get a master's. I didn't have a thesis in mind at the time, and I knew I got this internship with Amazon Robotics, and I saw what they did there, which was really awesome. So by the way, AR basically what we do is we automate the like warehouses. So the reason why you can get 2-day and 1-day shipping is because we have these processes and robots in the warehouses that speed up the whole process. After being an intern there and seeing the opportunities for me to grow and learn from these senior engineers who've been doing this for 30 years, I thought I could get a lot of practical skill and also get paid in the meantime before I really understood what I wanted to do for like my thesis for a grad program, which I'll probably do like in a year or two or so.
So let's rewind the clock just
Yeah,
like 30 seconds to when you said like yeah, you my Amazon internship. So
yeah,
AR means Amazon Robotics.
yep,
So um, I'm sure that a lot of people in high school who haven't been exposed to the college like process yet don't know what
yeah.
an internship means. So like when did you get that internship and how did that come about?
Yeah. So for most of the internships we get are all through the college fair system. We have this huge career fair in the fall and also a smaller one in the spring where all these companies come. So like Google, Amazon, Facebook, Oracle, like you name it. Barclays Center, you'll even have
Yeah.
reps there too. They'll all come to your school, and then you're walking around kind of like you see in the office, but it's not like Dunder Mifflin with a little piece of paper. Like literally you're talking to these people about what they do, what roles they have, and then usually for college students they'll have a summer program where you go over to San Francisco, or you go over to Boston, or you stay local depending on where the like place is, and you work for them. In most cases you get paid um, depending on the field, but yeah, you work for them and then you learn a lot, and then you build rapport with the team, and oftentimes it turns into a return offer the following year or 2 years later.
That's awesome. So
Yeah.
it's a great way to get your foot in the door at a company, get real practical experience before you graduate, and then hopefully build yourself some relationships so you can go back to that later. That's awesome. So I want to hear more about like Amazon Robotics because that's what we're all
Yeah.
here for, right? So like what kind of projects have you worked on and what kind of stuff have you been able to implement?
Yeah. So without getting into too much detail, that'll get me in trouble. So one cool thing about engineering, you could feel a little like elitist for a second. Like a lot of times you're not allowed to talk about your projects, which I think is the coolest thing.
Yeah,
There's a confidentiality,
absolutely.
especially like when like think about if you work for Apple with the iPhone, like you're all this anticipation for a new product release, and you see millions of people react to what you just did. It's
Yeah.
really a feeling. But without getting too much in the weeds, basically, we design like these robotic drives. They're probably like 3 feet long by like 2 feet wide that go and move around all the like inventory within a warehouse such that you can get your packages on time. And it sounds pretty simple. Okay, I'm just moving inventory around. But when you think about the scale at which we operate, we make hundreds of thousands of these like robotic drive units a year. They're all automated. They all work together in this like robotic fleet system, and they're moving millions of items per day. Just think about like how many Amazon boxes you probably get on your porch every day, and think about how many people there are in the world. Just like that's the scale at which we're operating at.
So like a really buffed up Roombas. So that drive around the warehouses and collect things and move them around.
Yeah, exactly. And
So
I think
why can't you talk about these projects?
so because there are a lot of, especially in outside countries, there's IP laws that are different within the U.S. and also globally.
Hmm.
And usually the global ones are less stringent than within the US. So outside companies will often see like some of the mechanical designs you do or the software designs you do, or pick up on like a method you're using that where you would lose the competitive edge. So for example, one of our biggest competitors is Walmart. They're also within the US, but outside the US, we also have a company called Alibaba. which sells a
Mhm.
whole lot of stuff, and they have very, very similar robots to us. Actually, if you look at it, the robots like nearly look identical, and that's
Yes.
just because of photos on the web, right, of our
Yeah.
stuff.
That's cool. That's really cool.
Yeah,
So, um, yeah, so that's kind of where there's a divergence between academic life, where if you're a PhD student, you want everyone to know what you're reading. You publish everything that you research, everything that you develop, you get it out there into the body of knowledge that's out
yeah,
there. But if you're working for a private company, you kind of like, in order to make sure that your company has that technology and you're ahead of the competition, you have to kind of
yeah,
safeguard those secrets. So
yeah.
it's a little different side of science there.
Yeah, until it's time for like product launch. Amazon Robotics is a little like different from the classic product launch teams, because our customer is ourselves.
It's
Like the
internal.
things I design are going to our like Amazon,
Yeah.
which is also really unique, because it allows us to like kind of have an R&D type of
Type of
like
feel to it.
design approach. Like where if you really mess up, it's not like the product is now in your hands and now you're complaining about it and you have to send it back. Like we could just go off to a different warehouse, make fixes if we want,
Yeah.
and like kind of do this iterative process. But I feel like I'm kind of rambling a little bit.
No,
Um,
it's cool. These are the things, like the ramble is what we want. Like we want to
yeah,
share stories and like we want to know these things.
yeah.
So so you design these robots that go into warehouses and move into inventory around. So are you working in a warehouse? Are you working in a lab? Are you working remotely? Is it a combination of these things? Like tell us about that.
It's definitely a combination, especially during these times. Ironically enough, there's a lot of mechanical engineering you could do without physically touching the parts.
Mhm.
So on a day-to-day basis, like what I'm usually doing is like using 3D modeling tools such as like SolidWorks or CATIA or like ShapeUp or OnShape, I think it's called. And we're making these models of these parts that represent the robots in real
So
life. And
let's
then
let's put a quick pause because I know that nobody knows what those softwares are. So all of those softwares you just named, you use them to build like digital 3D models of things.
yep,
Okay.
of the robots. And then from there, we would run all these different simulations to prove that it's going to work in the warehouse environment. So you have to think about the temperature of the warehouse, how rugged is the road, are there a lot of bumps in the floors, what type of like caster and wheel suspension system, very similar to like an auto vehicle we have
Yeah.
to think about. And then we do all these simulations in software right at home, like in my bedroom. I'm running these simulations for robots that are going to be like out there in the hundreds of thousands,
That's cool.
to see whether or not like they're going to perform over the lifetime that we say they're going to have. So a lot of that is kind of just remote. You could do really anywhere you want, which is pretty sweet. There is definitely a portion after like the design and simulation phase where you have to go in and build it and test it. And making that first build is probably the best part about being a mechanical engineer. Literally seeing it all come together almost never does. So that's one another thing. You have to accept failure just because that's just how everything's gonna.
That's
That's just
something we
how.
got it. We
Just
keep
how.
telling the students that
Yeah.
science is failure.
Yeah.
It's a systematic, like step by step failure until you get where you want to go.
Yeah. So actually, that's a great one of the models we have is just fail fast and learn quick.
Yep.
So basically, you want to
That's
prototype as
great.
quickly as you can. So you do that design and simulation phase really quickly. But
Mhm.
at a certain point, you're only going to get farther if you build it and learn why it doesn't work.
Yeah.
So baked into our like say our year-long program schedule, we'll have like half that time dedicated for making iterations and like making small tweaks to really increase the performance of your product before you launch it.
Cool. That's
Yeah,
awesome. So we've covered like a lot of like nitty gritty technical stuff.
yeah,
We really like dove into like Amazon and what you do, but the more like overarching theme that I want to tie together here is like, why is what you do dope? Like,
yeah.
why does what you do matter, and why do you enjoy doing what you do?
Yeah. So in short, I say like at Amazon Robotics, we reinvent the future. So what we're doing every day is like when you look at the drones that are like coming through, like with drone deliveries, or when you think about the future of automation, what I do every day is impacting like what everyone like Amazon's the standard of industrial automation and just how quickly you could get products on like virtually.
Hmm.
Um, and everyone follows what you're doing. So I feel like you're really setting an example for the future, and not just from like an automation standpoint is it cool, but I think what you're really doing is making products more accessible to the world. And I think that's a really nice reward when you see every day walking by, seeing like people getting their orders. in
Yeah.
a timely fashion,
You know,
right?
you had a
And you
hand in
know
it.
that you had a part of that. You know which systems are tucked, like you know why they're getting those products done, and it makes you more motivated to try to make the system even better.
That's awesome.
Yeah,
That's awesome. And that's a good answer. It's a good, concise answer. It's been awesome talking to you. You clearly
yeah,
like really enjoy what you do. You're clearly a smart person who works on smart person stuff. So awesome. Thanks for being here, man.
yeah.
And
Of course.
I'll tell your dad you say hi.
All right, we'll do.